a certain satellite is close to the Earth's surface and is assumed to take the radius of the Earth's surface as 6.38 times 10 raised to the power 6 meters. We are expected to calculate the speed of the satellite, okay? And then the period of rotation of the satellite. Two quantities, or rather two parameters are expected to be calculated in this question. So what we need to do is quickly we put down a solution. Alright? The first thing is that we're looking for the speed of the satellite. Take notes, it's not the escape speed or escape velocity of the satellite. No, we're talking about just the ordinary speed of the satellite with which it revolves around the Earth. Just the speed of the satellite. So that is giving us Vx, the speed of the satellite. The speed of the satellite. I don't want to waste time here. Okay? So the speed of the satellite is also stated mathematically as Vx equal to square root g me all over r. Okay? So we take note of this. With this, we can now calculate the speed of the Earth. But there is something here we must take note of as well. Me represents the mass of the Earth, but it's not given in the question. It's not given in the question. So let's look at the question once again. For a satellite which is close to the Earth's surface, its radius of orbit may be taken as the radius of the Earth, given as 6.38 times 10 raised to the power 6 meters, as I earlier stated or said. So a very close look shows that there is no value for mass of the Earth, but there is ME in the equation given or in the formula for calculating the speed of the satellite. What do? We recall that ME is given as G R E squared all over G. Okay? Go back to my former this, you will see this. If you watch my previous video, you will see where I evaluated this. So what we need to do next is to substitute. We now substitute for ME in this equation. We can call this equation number 1, okay? We can call it equation number 1. So we substitute first. And by the time we substitute, we have that square roots or square roots G for this ME, we have G all over R first, okay? All right? For ME, what we need to do, let me clean up this. For ME, what we need to do is we substitute the value for ME, which is GR squared over G. And then we have small g, RE squared, all over capital G. So we have successfully substituted for the value of ME in as this. We have taken this and then substituted it there. So the next thing to do, we cancel out wisely. G, capital G, we take care of capital G here. Alright? And then this is RE squared. This also is RE because we're taking reference from the Earth radius. So this is 2 and going to the lower by this. Finally, we now have Vx. That means the speed of the satellite is given as square root G R. Very simple. Look at it. Very simple. Look at it. Okay? We have arrived at something very important. We have the radius of the Earth. That's R. Okay? And we have G, which is given as acceleration due to gravity. G is given as 9.8 meter per second squared. That's all. So what do we need to do? We substitute. At this point, we substitute. We substitute, therefore, the value of the speed of the satellite can be found by taking note of the fact that The radius of the Earth is giving us 38, approximately 4. I can approximate this. Let me write this clearly. Taking note of the fact that the radius of the Earth, which is r, is giving us 6.4 approximately times 10 raised to the power 6 close. The acceleration due to gravity, g, is giving us 9.8 meter per second squared, and then we substitute that. 9.8 close all over. Any other thing? There is nothing again. I wanted to say all over, but there is nothing again. So by the time we simplify and find if we now further simplify this by simply saying 6.4, this is an approximation of 6.38, so take notes. Approximation of 6.38 times 10 raised to the power 6, that's what you're seeing here. And then g, the small g, acceleration due to gravity, is 9.8. So if we simplify all this, we are going to have the answer as 8.3 times 10 raised to the power 3 meter per second, right? This is the speed of the satellite. Number one question has been answered. Okay? Now, how do we now find the period of rotation of the satellite? That's another question we need to ask ourselves. How do we find this? Now we have found the speed Vx. Okay? So we can now write it clearly. Vx is equal to 8.3 times 10 raised to the power 3 meter per second. That's it for the satellite. We can also find the period of rotation of the satellite by using this formula. Let's clean up this side since we have understood this. We can also find the period of the satellite by using angular rotation of the satellite is equals to some amount of theta and then t as the time. Okay, we are looking for time. And this, if you're familiar with this, is equal to 2 pi all over t. Therefore, we can make t, the subject t becomes 2 pi all over w, that's the angular speed. But we don't have anything to do with this, so we can change it as 2 pi, taking note of r, because so far there is a circular movement, a rotation about a point. You must consider the radius of that point. So that's why we have r all over v. Now we are talking about v, okay, in place of angular speed. So that's the same thing. And that's the speed of the satellite, Vx. So we can now substitute. If we substitute, we now have t is equal to bracket 2, close bracket, open again, pi is 3.142. That's for pi. I'm substituting for this. This is 2. And then pi is taking this value. Radius r is taking this value, which is 6.4 times 10 raised to the power 6, close, all over the speed of the satellites, which we found to be 8.3. The speed of the satellites is given as 8.3 times 10 raised to the power 3, bracket close. Therefore, finally, the time, the period of rotation of the satellite is given as 5 points, or maybe 3 times 10 raised to the power 3 seconds. That's it. That's what it means. So look at it very well. Okay, there should be just ordinary 5. Let me rewrite this. For clarity purpose, that should be just 5.0 times 10 raised to the power 3 seconds. Okay? Look at it. This is the period of rotation of the satellites. So question number 2 has been solved. That's what it means. Look at it. Very simple. Okay, we've done justice to this. If you have watched up to this moment, thank you for your patience. Thank you for patronizing this channel. But don't forget to push on the bell button for constant notification. Give me some thumbs up and then subscribe. Subscribe, come on, encourage me.